see how all the projects are seen, adaptation, which strategies are communities implementing in different parts of the world, which are commonalities. But in this presentation, Dr. Filho will show us how this is probably seen more at the global perspective, and we will build from that. Thank you very much, Dr. Gylvan. It's a pleasure to have you here, and thanks for your help.
Thank you very much. It's a pleasure and an honor to be here with you. I'm new in Belém, arrived quite a few months ago, and because of the challenge Bali has established, the Bali Institute of Technology devoted to sustainable development, and I was invited and I accepted very gladly to help organize the group on climate change. You certainly saw in the newspapers and in the internet that on Thursday last week, the working group 1 of the Intergovernmental Panel on Climate Change, the IPCC, has concluded its work and has released the 5th assessment report, AR5, with all of the review of the human knowledge on the science of climate change. The last report, as you recall, was AR4, was released in Paris on the 2nd of February of 2007. On that occasion, they turned off the lights of the Eiffel Tower to call the attention of the world to the main conclusion of the panel, which was essentially that we have detected climate change unambiguously. And so there are no more doubts. And is even stronger now in the 5th report. It was released in Stockholm. They don't have a tower in there to turn off the lights, but the conclusion is extremely important. And as you know, we are in the middle of the process of negotiating a new agreement by 2015 to start working after the year 2020 on how to implement the decision of our leaders made in Stockholm in 2009, which was a decision to limit climate change to a value of 2 degrees Celsius in the increase of global surface temperature by the year 2100. So I will, because of this important event last week, I will focus on what is behind this result. The next, I agree. Point is somewhere.
Yes.
There. Okay. The way the atmospheric ocean machine, the way it works is it's an engine. And the reason why there is movement and transfer of energy and so forth is it's a machine that is driven by the fact that there is a flux of heat from the sun in the form of electromagnetic radiation in the visible spectrum, and it's in the visible spectrum because the radiation temperature of the photosphere or on the surface of the sun is about 6,000 degrees absolute, 6,000 Kelvin. And to that particular temperature, it corresponds to a spectrum of emission with a maximum in the green color, which is whereas our planet, the Earth, radiates energy in a wavelength that corresponds to our mean temperature, which is on the order of 300 Kelvin, and the peak of that radiation corresponds to the infrared spectrum. And let me tell you what a greenhouse is. A greenhouse is a box or a house or whatever that is covered with glass or plastic, and both of which they allow the visible radiation to go in and therefore warm the surface, and they block the outgoing infrared radiation, which is a property desirable by people who want to have a warm place to start growing their seeds or their little plants before the spring comes in. Our planet is a natural greenhouse because of the fact that certain gases in the atmosphere are opaque to infrared radiation. And it's interesting that 99% of the atmosphere does not produce the greenhouse effect because it corresponds to molecular nitrogen and oxygen and the noble gases, helium, neon, xenon, and so forth. And for quantum mechanical reasons, those gases, which are the majority of the atmosphere, they have symmetries, spherical or cylindrical, and therefore they do not absorb infrared radiation. All the other gases absorb infrared radiation and therefore produce the greenhouse effect. Notably, water vapor, carbon dioxide, methane, nitrous oxide, and all of those industrial gases, the chlorofluorocarbons. All the other gases are greenhouse gases. And the most important one is water vapor, but its amount in the atmosphere is not determined by human beings. It has to do with the equilibrium between water in the atmosphere and in the oceans. As the temperature increases, there will be a little bit more in the atmosphere, but in general, it's not the man-made emissions that determine its concentration. Now, that means that carbon dioxide, the second most important one, is the most important greenhouse gas generated by man. And as you recall, the modern scientific method, brilliantly written by Karl Popper in the Logical Scientific Discovery, the scientific method is simply a branch of philosophy or of logic, and the scientific method says essentially that anyone can propose a hypothesis, and this hypothesis should be tested against an observation of nature. This is different from the Greeks. I mean, the Greeks sat in a room and they said all matter is composed of combination of different amounts of earth, fire, water, and air, and they never bothered to leave the room and go outside to check whether this was true. The scientific method is relatively modern, but it is what we have. And the scientific method requires that every time you propose a hypothesis, you should also propose an experiment of an observation of nature that will, when you implement the experiment, will allow you to deny or not the validity of the hypothesis. Don't forget that by limitation of human nature, you can only decide that the hypothesis is not valid, but you cannot prove that something is true. You can prove that it's false, but you cannot prove that it's true. That's why scientists speak in a convoluted fashion by saying that the probability of something happening purely by chance is extremely small. The Higgs boson resulting from an experiment in Geneva, in Switzerland, with the Large Hadron Collider. If you read their official statement, they say, the Americans have decided that the probability of I detecting what I detected purely by chance without the existence of the Higgs boson, the Americans detected that this probability was very small, and I've now detected it. It's much, 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 much smaller, like 10 to the minus 17 and so forth. And that's the nature of the scientific method. It's looking at nature. Now, CO2 is increasing in parts per million in volume. It is, the other day I saw in the newspaper, it has reached 400 parts per million. Before the Industrial Revolution, it was at 280, and for the past 800,000 years, it has not exceeded 3 times. So this is new. We are entering uncharted territory by driving the CO2 concentrations in the atmosphere to this level. The origin of this is fossil, and only human beings release carbon from fossil origin. The reason we know that is that the amount of oxygen in the atmosphere is decreasing in the same proportion that CO2 is increasing. And this demonstrates that the origin is fossil, because every carbon atom from fossil origin, when it's burned, it forms CO2, and so oxygen in the atmosphere must decrease. So we know that, and with that increase, your greenhouse becomes more efficient, so you have a global warming. And the magnitude of this is comparable to what we would obtain if we had a 2-watt heater for every square meter of the surface of the planet. Not very high number, but it's turned on day and night for the past 200 years, so it eventually heats up the planet. Now, what is to be heated up are the oceans, and you know how much water there is in the oceans, and you know the specific heat of water, and therefore the heat capacity of the ocean, and your conclusion is that the temperature increases, will increase by the end of the century, about 3 to 4 degrees Celsius. It has already increased by about 0.7 degrees Celsius, which is exactly the number that you calculate by looking at this. This is actually the first law of thermodynamics. Now, this climate change, due to the anthropogenic increase in the concentration of greenhouse gases, is superimposed upon the natural variability. Now, the IPCC calls climate change any change in climate, whereas the convention of the Kyoto Protocol, they only refer to the human-made portion. Now, the climate change that is of interest to the United Nations, to the convention, to the protocol, and so forth, is a variable that cannot be observed. When you observe climate, you observe that climate change together with the natural internal climatic instabilities, such as El Nino or La Nina, the effect of volcanoes, the effect of solar variability, the effect of aerosols, and everything. So in order to separate out or to unshuffle things, what you have to do while staying in line with the scientific method, you have to compare your conclusions with observations. Since you don't have observations of the future, you only have observations of the past, what you do is to build a computer model and run it in a supercomputer, which is physically very simple. Those are the laws of conservation of matter, of energy, and of momentum, commonly called Newton's law. And you integrate numerically and make a prediction of the climate for the last century. In every research center in the world, you get a different result, and you compare with observations in black. And our ability today to simulate or to predict the climate is extremely good. Don't forget that climate is a mean or an average, and in average you are able today to reproduce the climate that was actually observed. And since this is a computer program, you simply turn off the portion that represents the effect of the increased concentration of greenhouse gases. And then you obtain the blue curve, and what the scientists say is that the probability of observing the black curve simply by accident, without resorting to the consideration of the increase in greenhouse gases, this probability is small. This figure is from the 2007 fourth assessment report of the IPCC. The new one, it's already in the internet, you can look it up. 6 years have passed, so this curve goes up, and the distance between one and the other is even larger, and the uncertainties are smaller. And that's why the scientists say I detected climate change unambiguously. The climate change is actually the difference between the red and the blue curve. It's this difference that worries. And now we are at a stage where we have gained confidence in making predictions of the future. And uncertainties are relatively small. This lower curve represents what would happen if you stabilize concentrations at the present value. The red curve is the curve that we are following, and the green and blue curves are policy options. In 2007, Madame Angela Merkel, at the time presiding the European Union, proposed in a meeting of the G8 plus 5 that we develop a pact to limit climate change to 2 degrees Celsius by the year 2100, that we call the blue curve. At that point in time, the US disagreed, Brazil disagreed, never understood why, but that position changed later on in 2009 in Copenhagen. Everyone agreed to follow the blue curve. That's a big challenge because, and this is, I'm very proud of this. This is an essay that appeared on Nature in 2008. It shows 3 people here. Bertolini, he has already passed away. He was the first president of the IPCC. John Alton and I, we were both co-chairs of the science working group of the IPCC. And this cartoon is because the essay speaks about the importance of using the scientific method. You discuss a lot, but then you have to actually go there and measure things to find out whether your hypotheses are bad or not. And it's in 9th of October 2008, in a series of meetings that changed the world, because that has to do with the IPCC Science Working Group in Madrid in 1995. That was the first time that the IPCC said, look, we are beginning to see the human influence on climate. Out of curiosity, even though you have several other effects that can change the temperature, it's only the increase in the concentration of greenhouse gases that has the property of increasing the temperature of the surface and decreasing the temperature of the stratosphere, which is interesting because if you cool the stratosphere, the outer layers of the atmosphere, they contract, and that decreases the aerodynamic drag on artificial satellites. And that is already being detected, which is a further evidence that this change is due to the human influence. Now, from a policy point of view, in order to stabilize the atmospheric concentration of greenhouse gases, and therefore the temperature, the emissions will have to be reduced by about 60% with respect to 1990. And that's the global emissions. No politics. I mean, the emissions are the same, whether they come from Switzerland or the Central African Republic or Brazil or China, whether we are rich or we are poor, it doesn't matter. I mean, nature does not take into account the social and economic aspects. You have to reduce the emissions by 60% with respect to 1990 levels, not triggered if you consider that we have already increased our emissions by about 25% since then. And you'll have a time lag effect. If you have an emission of methane at year zero, there is a maximum increase of temperature 20 years later. And in the case of CO2 and nitrous oxide, about 50 years later, which means that if you want to stabilize the temperature in the year 2100, you have to stabilize emissions by 2050. And because of the fact that industrial facilities are designed and built to last 40, 50, 60 years, it's about time to start doing that. You compare different gases by using equivalent factor, either the global warming potential, which measures the total amount of heat energy that is going to the system, or now the global temperature increase potential, which measures the amount of increase of temperature. And people are using 100 years. And it's interesting that in the case of methane, if you look at the energy of the GWP, the equivalence factor is 23, and if you look at the temperature, it's about 4. And that is important in the case of cattle, because cattle emits methane, and you are dealing with wetlands. Fundamentally, there is also an emission of methane in there. Brazil never, at least in the first national communication, did not add the emissions of different gases in terms of CO2 equivalent because of this. And if you want to know more about the science, look at the IPCC, the first site is the United Nations Framework Convention on Climate Change, and the third one is not
Thank you, Dr. Ben, for this very clear presentation of what we have, the problem that we are having today. And then this is a good opportunity to open the discussion that we'll have in the afternoon on how we are coping with that. Now we have a sort of clear understanding of why we are having trouble. In the afternoon we'll try to concentrate on what we can do, or what people who are suffering from the consequences of all of that is doing, or is trying to minimize the impacts that climate change is facing in societies as a whole. On some groups more vulnerable than others. Probably we'll have a few minutes later for some burning questions. If there is something that we could take advantage of having Dr. Gylvan here, you know of this is the authority on the issue. So if you have any questions that you can pose to me, this will be a good chat.